In this video, we'll discuss 95% confidence intervals and what they tell us about our data. In a previous video, we looked at a random data set for some volumes, and we found that from the 5 points that we had, we could exclude one. Now, working with the most refined data set, we have an average value and a standard deviation for 4 different observations. The confidence interval mu is calculated as the average plus or minus some confidence interval Ts over root n. The t statistic is discussed at length in other sources and won't be discussed here, but you can calculate the t value easily by using the t inverse function in Excel and stating the appropriate level of probability. So in our case, we're going to use the 0.05 level and then the number of degrees of freedom, which in this case would be 4 minus 1, so 4 observations minus 1. And so plugging that into Excel will get you the t statistic that you need to use experimentally. So plugging in the values that we have, we get our confidence interval as 0.5491 plus or minus t, which is 3.182 at the 95% confidence limit for 3 degrees of freedom, times the standard deviation that we computed before divided by the square root of the number of observations, which gives us a 95% confidence interval of 0.549 plus or minus 0.004. And we report one additional non-significant figure as a subscript to eliminate or reduce round-off error. So what exactly does the confidence interval mean? The standard deviation is the region around the mean where 68% of the distribution lies. Now this is true in theory. However, in practice, we do not make enough measurements to truly sample the distribution properly. In these cases where limited data is collected, we need a way of trying to represent the true mean based on our experimentally determined sample mean. That's the confidence interval. Another way of looking at this is a measure of the null hypothesis. In statistics, the null hypothesis is the hypothesis that all of our data are meaningless. In this case, that we are not actually truly measuring what we believe we're measuring. The confidence interval, in turn, is the measure of the region in which we believe the null hypothesis is less than 5% likely to be true.